Hello everyone. So today we are going to solve this LeetCode problem, which is number of steps to reduce a number in binary representation to 1. Okay. So what this problem says, let's see. We have been given a binary representation of an integer as a string and we have to return the number of steps to reduce it to 1. Okay. Also, today what we are going to do, we are going to approach it with the interview style. Okay. Like we'll see what the question says, understand the question, we'll apply a brute force approach, and we'll see how we can optimize it. Okay, that's the approach that you should follow in the interview. Okay, so we'll see that. Okay, so what we have been given a binary representation of an integer s, and we have to return the number of steps to reduce it to 1. And what operations we have to follow? The first is if the current number is even, then we have to divide it by 2. And if the current number is odd, we have to add 1. Okay. And it says that it is guaranteed that we'll always reach to 1 for all the test cases. Okay. So suppose we have been given this 1101, which is 13 in binary representation. Then 13 is odd, then we'll add 1. It will become 14. Now it is even, we'll divide it by 2. It will become 7. Again it is odd, we'll add 1. It will become 8. Then 8 is our even, we'll divide it by 2. We'll have 4. 4 is also even, we'll divide it by 2. 2 is also even, we'll divide it by 2. And finally we'll get 1. So we have to do these operations consecutively until we reach 1, which is our goal. Okay, and what we have to written, the number of times we have done these operations. So how many number of times we have done these operations? It's just 1, 2, 3, 4, 5, and 6 number of times we have done these operations, so we'll written 6. Okay, so so see, we understood the question. What the question says, that we have been given a binary string, and what we have to do, we have to convert it into an integer. Okay, because in that integer we'll check if that integer is odd, we'll add 1. If it is even, we'll divide by 2. Okay, so we understood the problem. Okay, so that is the first step, that understand the problem. If you have any questions, ask the interview the following up questions that you have any doubts. Like suppose he has not mentioned that it is guaranteed to always reach 1, then we would have to apply those edge cases also in which our answer would not be 1. But here it says that it is guaranteed that we'll always reach 1. So we'll ignore these edge cases now. Okay. So let's see what will be the brute force approach. Brute force approach is the first approach that we can think in our mind, or the simplest approach to solve this question, which can be if we convert our binary string to integer and or consecutively apply these two operations until we get our given integer, we'll convert it into 1. Okay, so how we can do it, let's see with the code. Okay, so what we have been given a binary string, suppose s. So what we'll do, first we'll suppose convert it into a integer, which is using sti function, and we'll say that it is a, this will suggest that this string contains a binary string. Okay, so we'll get a binary string over here, and what we can do, we can run a while loop until our nums become 0, nums become 1. Okay, if it becomes, and we can take a variable to store our answer, which is which will give us the count, how many count we have done the operations that we have to. Okay, and what operations we have to, if we have to check if our num is odd, then what we have to do, we have to add 1 in our nums, whatever the our num means, whatever our integer value is, and if it is even, then we'll divide it by 2. Okay, these two operations we have to perform, and simply in each iteration we'll update our answer, because in each iteration we'll do either this operation or this operation. Any two operations we'll be performing. Okay, so our answer will getting updated anyways. Okay, and finally what we'll do, we'll return our answer. But what we have done, we have used this function. Okay, so for a very long binary string, it will give us TLE. Okay, what is this? Time limit exceeded. Okay, so its time complexity is not very good. Now we'll think how we can optimize this problem. We'll think how we can optimize this problem that we'll not get TLE. Okay, so first you'll tell the interview about this approach. Okay, you'll not write the code, you'll just tell the approach. Then he's asked how we can improve it. Then you'll suggest the optimized approach. Think of an optimized approach. Okay, we have been given a bit representation. So whenever you are given a binary representation, just think about what can you do any type of bit manipulation or not. If you can play with bits and find the answer, it's best, because here we have converted into integer and done every operations on the integer itself. Okay, we have not performed any operations on the bits. Okay, which will give us the more efficient solution. Okay, so now let's think how we can approach this. So suppose let's take that example only, 13. This binary representation we have been given. So how we can convert this, find the number of operations? So see, while traveling from LSB to MSB, we see if our current bit is 1, which means it is odd. Okay, because this represents 1 and these all are some power of 2. Okay, if we add 1 to the sum power of 2 addition, then only it keeps our odd. So that if LSB has 1, then it is odd. If LSB has 0, then it's even. Okay, that much we know. So what we can see, if our current bit is 1, then what operations we have to perform? We have to add 1, and adding 1 will always give us a higher number. We will not ever have 1. Then it's obvious that we have to perform a divide operation after that. Okay, that we are confirmed about. So divide operations we have to also perform. Up suppose this bit would have been 0. Okay, then what we have to do, we have to divide it by 0. Okay, so only one operation we have to perform. So, because it could be divide by 0, 2 divide by 2, then it could have become 1. Okay, so for even we'll consider only one operation. Also, what else can be there? It could be that we would have generated a carry of 1. So if carry of 1 have been generated, it could be either 0 1 or 1 1. These two possible conditions would have been there. If it is 0 and 1, then we would have to do plus 1, which means it is odd only. Okay, then also we have to perform two operations, that is plus 1 then divide by 1. And if it would be 1 bit and carry would also have been 1, then it would become 2, that is an even number. Then it may be possible it would have been 2 and we'll divide it by 2, we would could have get our 1. Then what operation? Then only one operation we would have performed. Okay. So from this we get our four conditions which we can apply on bids. Okay. Now let's see how we can implement this logic in the code. Okay. So first what we have done, we have we can take a what we have been given our binary string only s. Okay. And what we have been done, we can take a variable in which we can count the number of steps and another variable in which we can store our carry. Okay. Now we have iterated from LSP to MSP. Okay. Which is in I equal to s dot len minus 1 till I greater than 0 and I plus plus. Okay. And we would have checked if our current bit plus carry is odd. If current bit and plus carry is odd, then what we would have done, we would have done two operations, then number of steps would have been incremented to 2 and we would have generated a additional carry of 1. Okay. And if it would have been even, then we would have updated our steps to 1 only. Okay, that we have checked. And you can see we have only iterated to 1 less than MSP. Why? Because at last what we can return, we can simply return our number of steps plus carry. This carry would have counted our MS for our MSP. Okay. If our MSP would have been 0, like it would have been 1 in, then it would have been carry 1, the number of steps would have been increased by 1. If it would be 0, then our number of steps would have been remain same. Okay. Let's take that example also. 1101. Let's try run this. Okay. So first we would get our 1. Initially our carry is 0. So 1 plus 0, it is 1. That means it is odd. Then we have incremented our steps by plus 2, means step count is 2 over here. Okay. And a new carry would have been generated. Okay. Carry would have been 1. Then again, which what bit we have been? We have iterated to 0 bit. Now 0 plus 1, 1 is our carry now. It would have been become 1. Then we'll again have incremented our steps 2 plus 2. Now it would have become 4. Okay. And again our carry would be 1. Okay. And then we would have iterated to 1. Okay. Then 1 plus 1 would have been 0. Then only one step we would have added. Okay. Now our number of steps would have been 5. Okay. And our we haven't not updated anything when the carry is even. Okay. So what would be our final answer? Our final answer is steps plus carry. We have not iterated to MSP. Okay. See that. We have not iterated to MSP. Okay. So final steps plus carry would have been 5 plus 1, which is 6. Okay. Because this carry will always be 1. Okay. Because we have not updated anywhere our carry equal to 0. Okay. So this would always give us MSP because we know our MSP is 1. Okay. That information we already have. So this would give us our final answer. Have you understand that? If you have any doubts, just rewatch this video, okay? And if you have any doubts, just put it in the comment section, or any suggestions that you have. And keep learning, keep growing. Bye bye.